All right. You can see this is a column cross section from an existing drawing. I just picked that and I pasted here. Okay. So you can see here now, we have the depth of the foundation from here now to this place. You can see this is actually that base that we just did the cross sectioning for that base. So, but you know, we are not showing this base here in the column. All we are interested around this column is to show the detail of that column. Okay. So the detailing of this column now, you can see this is the reinforcement coming out from the foundation. We have 4Y16. Here we also have 4Y16. We also have 4Y16 here. So what that means is that the column from the foundation level is coming out as 4Y16 up to your roof level, 4Y16 all through. There are cases whereby your column reinforcement in them may not actually continue in that way. Okay. Most especially when you are having probably maybe, let's say, 3-story building. Okay. There are cases whereby you may start from the foundation with Y20, and then on the first floor, you may have Y16. On then the second floor, you may have the same Y16, but you are starting with Y20. So it depends. Okay. It depends. All you are interested in is the stability of that building. Okay. Because as an engineer, you have to put so many things into consideration in order to do your design. So but after doing all of that, once you analyze and you do your design and it's telling you that it's safe, then you come back here and do your detailing. So we are assuming that based on our design, that Y16 was what was provided all through. But if you check the detailing here, I think exactly what we have. Let me share screen to my photo detail. I think this is it. All right. So you can see this is exactly what we have. If you check the cross section of this detailing from the prota detail that we generated, you can see this is 4Y16 on these are for the first floor, I think. Yeah, this is for ground floor. Okay. So you will see, you discover that the reinforcement provided is 4Y16 all through. From the foundation level, which is this, from here now to here, is 4Y16, to the first floor level, up to, even up to the roof level. Okay, it is 4Y16 all through. So that is exactly what we are actually using here. But you can see from the design here, I think this is the depth of that foundation was 1,100. Okay, so you can specify that in your detailing there. Okay, whatever you must have used. So, but from this detailed drawing, I think this is 1,100. This was what was used in the analysis and the design of this particular structure. So if we go back to your detailing, you can specify that, okay, to be 1,100. All you need to do is just to change it from here, that information, instead of sketching this all over. That means this drawing is not going to be drawn to scale. This is not drawn to scale, okay? So if you change this to 1,100, you can see the spacing of this reinforcement is to 200 spacing, okay? So whatever you use there is the information you specify here. So let's confirm what is the spacing that we actually made use of here. Okay, I think the spacing here should be one, is also 200. Let me do that maths here. I have 3,850 divide by 200. I have 19. Okay, divide by 150. Let's see. Divide by 175. Okay, 180. So I think they use 170. So this is 170 spacing. The spacing that was used here is 170. Okay, is 170. If you multiply, if you divide this height divided by 170, you're going to have 23. Okay. Okay, this is for the links, right? Yeah, this is for the links. So I have 170. Okay, it's written here. Sorry, 175. Okay, 175 was what was used here. So you can use that same data that you get here. All you need to do is just to specify them in your structural detailing here. Okay, so let's come back here. So I have this to be 175, and then I have this height to be 110, 1,100, and then I have the height of this. This height is always gotten from the elevation given to you by the architect. You'll be able to know the height of that building. So most height of building for normal residential building falls around 3,000, 3,150, 3,200, 3,300, within that range. Okay, so all you need to do is just to specify the height. It is not in your position to make provision for height. It's based on whatever is given to you from the architectural drawing. The height of building varies. It depends on whatever the architect must have used. Okay, when it comes to warehouse, when it comes to workshops, most times the height of those their headrooms are always higher. Okay, so you don't assume a particular height. You use the height that was given to you from the architect. Okay, so so if there be any information that is missing that you are not sure of, you have to actually make inquiry, ask the architect what is the height that he used. If possible, get the elevations, okay? In order for you to know the height from the elevation, you'll be able to know the height. And then while you are doing your analysis, all these come from when you are doing your analysis. All these informations are already there while you are trying to do your analysis, okay? So while you are trying to analyze the building, doing your design, all this information, you must have gotten all of them. Okay. So so assuming that this height is 3,300, and then the height from here to here is also 3,000. Okay. So you can see the reinforcement here is just an indication. We cannot show all the reinforcement because this is a cross section. So in this cross section is telling you that here, here, and here we have two reinforcement here. But if we are to show it, this is going to look a bit more clumsy. Okay, so that is why you can see a donut here, another donut here, showing you this is the reinforcement you have is the same reinforcement you are going to have here. Please don't call me on a normal call if you want to talk to me. Just drop me a message. It will disconnect whatever I'm doing right now. All right. You are not seeing my screen. Let me switch it. Sorry. I switched it to AutoCAD, to Prota Detail. I'm taking it back to AutoCAD. I believe you can see my screen now. Please let me know if you can see it. Okay, good. Now you can see, so that is the point I'm trying to make. You can see the height of this building is determined, like I said, from the architectural drawing. Okay, so the cross section, like I said, this reinforcement, drawing a sample is going to take me much time now to achieve that. It's going to take me much time to achieve that. It's going to take a long time to achieve that, honestly, because of, but there is nothing confusing about this now. It's just to reproduce this as it is. If you are drawing this line, just the thickness of the what they call it, the thickness of the column is 230. All you need to do is just to specify. You can see this one is not drawn to scale. Then you draw the normal base is 1,200, 1,000, 1,000. You just draw a line here. Sorry, let me get the center. 500. It's going to take me a longer time to achieve. Now, if you want to be doing your detailing from AutoCAD, everything from scratch, it's going to take you forever to finish. To finish one project, you are going to take probably maybe 2 weeks for a very small project to achieve. And that 2 weeks is going to take you a very long time to achieve one particular drawing. So a drawing that probably maybe the client is not even paying you much in the first place. Because most of the clients now, honestly, they are not really encouraged. If you take the depth here, which is 500, it's just to reproduce it. You are just doing the same thing. It's just a cross section. You must understand cross sectioning. This is the base. If you take 550 here, it's going to take me time. Then the reinforcement is what you have that comes this way. You have to take reinforcement. It's going to take a longer time to achieve that. And take the depth of the foundation, 1,100. 1,100. Then the thickness of that slab or in your German floor is 1,150. We cannot do this thing afresh from scratch. It's going to take a long time. This is 150. The other height from this German floor now to the main to the ground floor height is 3,300, assuming this is what we got from the architect. Another slab, we are having another slab here, which is 150. You take that. Then your roof level, which is another 3 meters. But you know, here we are using a normal, this is your roof beam, okay? So this is your roof beam, it comes this way, and the thickness of your roof beam is 300. Here you are going to have a drop of 450 because the beam here is actually 450 thickness. So this is how it's going to look like. And then you use a continuity sign to show that this beam is actually continuing. This slab is continuing rather. How do they even do this thing? So I forgot. Sorry. Yes. So it's just a continuity sign to show that this actually continues. You can just showing you that this actually continues here. You can, I think I didn't get this right. I've forgotten how to do this thing. So I don't sketch afresh. Okay. That's it. The same thing. The same thing you do here is what you are going to do here. You just mirror this. This is continuity sign. You use the same this thing for the one you use here. It's actually what you are using here. This is also another slab. So this is it. So you have your reinforcement coming from the foundation. You are also going to have another reinforcement that is actually starting from here. But you know, this one will come and then there is an overlap. Please, site experience matters, design experience matters. All these experience will help you to be able to come up with your design. So it's not something you can. This one will a bit shift like this because you are actually going to have your reinforcement from the column entering this the beam. Okay, because here you have a beam here entering the beam. That is why you have this one staggering this way. So it's the same. Then you have another this coming this way to stagger, enter this. So this is just a typical example of how your column is like. So there's no, it's just to, then you have to fix all these things in layers, you know, put all these informations, you know, to give it detail. That's just how to draw this. It's very easy to actually come about this. There's no need of you drawing this afresh, except in a case where you have a new type of probably column that you don't have among your templates and it's completely different. Even if you take the cross section of a circular column, it is still going to show like this. Only when you cut it from here, that's where you are going to see a cross section. By the time you cut probably here and you are looking this way, and you are looking in this direction or even the other direction, then if this is a circular column, you are going to see from that cross section like this, just to show you. But from here, around here, you are still going to have it this way. So whether it's a circular column or is a rectangular column or is a square column, except in the case where you are having maybe like a hexagonal or another kind of, but it will still show in this form, only that it may look a bit bigger and all that. So you need to lay your hands on different samples of detailed drawing. Like I said, detailing is not something you can learn in one day. You keep growing every day. I myself am growing every day. I have bosses too. I have people I run to whenever I have a challenge. I have colleagues I will run to. I will ask, please, have you done a particular design on this before? And then if yes, please, can I get a sample? Can you put in more light to what I'm doing? Like that. That's how you grow. You can never finish knowing it. And even till the day you die, you will never finish knowing it. Honestly, till the day you die, you can never finish knowing it. So it's actually wide. I'm not saying this to discourage you, but that's the truth because it's wide. We have different kinds of building coming up every day, different shapes, different, you know, different span and all that. So, you know, people are thinking deep, most especially in the Western world. You know, people are thinking very, very deep. And so you have to think critically. So the detailing comes out exactly as it is. You cannot, this detailing is exactly what, it is where me too, I'm running to some other people, some other senior colleagues. It must not be somebody who has been into design before. Sometimes there are people who I started design before them, yeah, before them, and then I still run to them too, because you know there are some probably maybe some exposure that particular person must have gotten, or some particular experience that person must have gotten that you have not been opportune. It's an opportunity to get experience. There are experiences that is an opportunity. Honestly, it's an opportunity. I myself, it was an opportunity for me to find myself in consultancy. There are people who tried so much, but they could not really get that opportunity to really even find themselves in consultancies like that. While there are people who will get the opportunity and then they will actually not make use of it. So that is just it. So it's the same way. What you have here is just to spice, there's nothing different. It's just to spice up whatever you're detailing, make your detailing much more presentable and more readable, that whoever is seeing it will be able to easily interpret it. So this is exactly how your column detail is going to look like when you detail it. Okay. So you are going to have your column detailed in this way. I think there is another information that is missing. Okay. So sometimes, okay, let me just pause there. Okay. So like I said, this is coming from this is the base level. This is the foundation level that you must have digged. This is the column coming from that foundation level. This is the ground floor level slab. Okay. But we are not giving detailing for slab in our column cross section. Our concern is the column itself, because we have already given their detailing separately. Okay, we have given the detailing for our base, so we are not concerned about giving detailing on base here. So, but this is just showing you that this is from the base. This is showing you at the foundation level, you are having 4Y16. And like I said, this is bar mark. You are just giving your reinforcement names. Just like when they gave birth to you, they must have given you a name. So you can decide to give this one a particular name. So whenever you come across any other reinforcement that is exactly like this, in the same size, the same shape, the same thickness, everything is the same, you definitely give it the same name. They are the same. So anytime you have an identical reinforcement that are similar to each other, you give them the same name. So this is just a name. So this is O2, this is O3, this is O4, because they are different. This reinforcement here, the length from here to here is actually different. Okay, and then this length from this reinforcement, because this reinforcement is definitely going to stop here. You have a roof here, but you can see this reinforcement did not just stop here. It actually entered into the other column that is at the top, because it has to overlap with this. Okay, so it will overlap with the other reinforcement at the other floor level. Okay, so that is another thing you need to actually take note of. And then your overlap. Okay, please, I am always referring you back to that book, Victor Oyenuga. Please lay your hands on it. Okay, there is a simple calculation you can do for that your overlap based on the thickness of the reinforcement. You multiply by a particular value. Please, I have so many things in my head. I cannot even remember it right now, but please lay your hands on it. It will help you to you can fall back to it always. Whenever you want to do your design, fall back to it to check. There are standard you use. Okay, they are standard based on the thickness of the reinforcement multiplied by a particular value. I cannot remember, and then you'll be able to get the overlap that you're supposed to use. And in most cases, overlap always is within the range of maybe 650, 700, 750, 800. Please, it's not a constant value. Okay, it's not a constant value. That is why I always refer you back to that design book. Okay, please get a design. Thank God you already have it. Like you said, please visit that book and study it very, very well. It's very important. Okay, it will help you in your design. So this is all about column detail. There is no big deal as to what column detailing is all about. Now, if you check this design very well, you are going to see that this is for your links too. You can see you have the same size of links. They are spreading the same thickness, the same width. So we have Y1005 here at 200 spacing. So if you take this height 3,300, divide it by 200. This is the value you are going to get, which is 16. Okay, so 16Y10,005 200 spacing links. Okay, the same thing for here. You take the height, which is 3 meters, divide it by the spacing, which is 200 here. But from our detailing there, I think it's 175. So if you divide by 175, you are going to get that value. All you need to do is just to type in that value, and then you come here and you change the spacing. It's very simple. That is why just get a detail, an existing detail drawing. Once you already have existing detail drawings, you can from there be changing them to whatever informations just to make your work easier and faster. The major thing you need to know is how to interpret this thing properly. And because we have 4Y16 here from our cross section, by the time you cut this column, okay, let me try to take a cross section. So let's say I take a cross section of this column. Let's see from here, for example, SC. So if I take the cross section of this column here, this is, and you can see this is pointing up. That means I'm looking up. So I'm going to have 4 reinforcements here. Here it says 4Y12. So I'm having 1, 2, 3, 4. Okay. Here it says 4Y12,04. The bar mark is 4. Okay. So you can see 04, 04, 04, 04. The bar mark telling you that this reinforcement is the same reinforcement with this, the same reinforcement with this, the same reinforcement with this. There are cases whereby in your design, you may have maybe 2 different thickness of reinforcement in one cross section, where you may have Y16 combined with Y20. Okay, it's possible. That is why your experience matters a whole lot. Okay, your site experience matters a whole lot. Okay, so there are cases like that. Even the design, even Prota structure can provide that for you, where in your detailing it will provide maybe 2 different diameter of reinforcement in one cross section. So, but here now we have the same reinforcement, so they are having the same bar mark. So 04, 04, 04, 04. Then this links here is 005. That is the bar mark. So that is what we have here. This is pointing at the links. This is 005, Y10, 05, Y10, 05. That is the bar mark. These are just bar marks. I hope you understand. And then the thickness of this column, the size of this column is 230 by 230. And then this cross section here, I named it 1. So I can decide to change it to 1. So it's the same thing. You don't have to keep redrawing or doing all this drawing afresh. There's no time to be doing all that. If you want to be doing all this drawing afresh, like I said, it's going to, just for this very simple structural design, it can take me maybe even 2 weeks to achieve. If I want to start drawing all this thing afresh, it's going to stress me a whole lot, and then it's going to take a whole lot of my time. Okay, so the main thing is detailing is you showing how your detailing should look like, real life on site. So only that this one now is not drawn to scale. So you can specify it in your drawing that your drawings are not drawn to scale, so that somebody will not go and carry ruler and trying to measure the dimension on site. Okay, so you can specify it's not drawn to scale. Okay, so this is not drawn to scale. Okay, all right. The main thing you need is the information, which is this. These are the informations here. Okay, I think, oh, the cross section is even here, the main existing one. So, but I'm going to take it off since I have already introduced another one here. Okay, so we can see this is what we have. So it's exactly what we have. So this is how to come about your column detail, irrespective of whatever kind of column you want to actually detail, whether it's a circular column, whether it's a square column, whether it's a rectangular column. But then I stand to be corrected anyway, because I know a lot of people are going to be seeing this. So please, if you have other opinions about columns, I would like you to share. Okay, so you can share that knowledge. I am very, very, very open to new knowledge every day. I like to learn. I cannot know it all, and I will never know it all. That's the truth. I can never know it all. So you keep on growing every day, every day. As you are learning, you are growing by the day. You are growing every day. You are growing every day. You are learning from people, okay? And you are teaching people. You are growing as it goes, like that. So that is that. So another thing is here, you know, you have this space you are seeing is the concrete cover, is the concrete cover. So, but you know, you have already specified your concrete cover. Maybe in your design review here, you can, okay, I don't even have any here. Let me see if I have any here. This section will soon be over. I think I have just 16 minutes from now. Can you still see my screen? Because I opened a new AutoCAD file. Please let me know if you are seeing it. Okay. I'm trying to show you something, and then my mouse is misbehaving. I need to go get another mouse. I need to do something about this quickly. It's going to affect my job. I just have 5 minutes more. All right, you can see these are general notes, okay? Discrepancies and dimensions. You know, in case of any discrepancy, refer to the structural design engineer for clarification, okay? All dimensions must not be scaled. Work to figure dimension only. Any missing dimension should be referred to the structural design engineer for resolution, okay? So by the time anybody is going to decide trying to use a particular ruler to confirm a dimension, you may not be getting the right information, okay? So this is just a general note stating all of that, and stating the thickness of the grade of concrete that was used in the design, the grade of steel that was used in the design, all of these abbreviations that was used in the detailed drawing. Okay, so all of this information, the soil bearing capacity, you can see the what they call it, the concrete cover for each of those structural members, all of them is actually in the general notes. Okay, so that is that. I think I have just few, maybe 3 minutes for this section to be over. Okay, so I have shown you foundation layout, I've shown you the base detail, I've shown you the column detail. On our next meeting, I'm going to be showing you how to actually come about your slab and your beam layout. That one is actually not going to be that difficult. It's not going to be difficult, actually. I'll be showing you the slab and beam layout. Then, yeah, after that, we are going to the slab detailing. We are going for slab and beam layout. After then, we'll go to slab detailing. After then, we'll go to our beam detailing. Then we'll come to our roof concrete slab / beam layout. Okay, so that is that.